much for joining us, guys. This is discrete structures, or officially इसको हम quantitative reasoning 1 कहते हैं. Okay. Let's get started. About me, I am Dr.Mudassir Shabbir. I am an associate professor at ITU. I have been at ITU for last almost 10 years. Okay. In September is going to be 10 years exactly. Before that, I was at few places. I'm going to show pictures of those places, and you're going to guess what those places are. What's this? Raise hands. Below? This is PUCIT or Punjab University. I did BS from there. This is LUMS. Everyone knows this. This is Rutgers. I did my MS from there, New Jersey. This is also Rutgers. I did my PhD from there. This is a cute little place called Los Alamos National Labs. I did my internship there, and this is interestingly the place where the first atomic bomb was designed and constructed. This is the lab where they kind of constructed the first atomic bomb. Okay, so I did an internship there in summer. It's in New Mexico on the border of US and Mexico. This is, some people recognize it. Do you? Do you know what this place is? This is Bloomberg headquarters in New York. If you look at the corner, maybe you can read the words here, okay? I also did work there. Oh, did I miss a few slides? There are a couple of places that I wanted to mention. Okay. Okay, एक आधी जगह रह गई है. Okay, so I was from February 21 to February 23, I was at Vanderbilt University, which is also in the US, and I was actually teaching there, okay? I missed those slides because it's a beautiful place. I should have added those. Anyhow, okay, so I've been to a few places. I did my PhD in discrete math, so you can trust me when I talk about discrete things. My research interests include graph neural networks. We will learn in a bit what graphs are. In a bit, I mean in few weeks. And also discrete geometry. Yeah, most recently I was a research assistant professor at Vanderbilt University. You can use the clicker as well, right? Yeah, so you already know Ravid and Nirmeen just left, I think. We're going to have 7 other teaching staff or volunteer TAs: Abdurrafe, Barira, Sara, Hamza, Naveed, Mehreen, and Saleha. Saleha is, I think, at the back. You haven't met her yet. Stand up. Okay. These are actually the star students from the last year. So they're going to be part of the teaching crew this time. Okay, get to know each one of them. Okay, you should know them by face and by name. Reaching out, we are going to be using Slack for discussion, so I want you guys to join the Slack as soon as possible. That's the best place to get in touch with me and with any of these guys. Okay, you send them a message there, you'll probably get an answer within a few weeks. Hours, okay? You can also send me an email, okay, Mudassir Shabbir at ITU. I would suggest that you put discrete structures in the subject line, okay? So, for example, if you're sending me an email about, for example, a homework problem 1, so at the end, add discrete structures, okay? It will help me reach to you earlier. I kind of receive about 200 to 300 emails which are not spam, and I have to go through all of them. So it helps if I know that it's a relevant email or not. Okay. I would suggest कि आपकी जो email है वो it's formatted well. That's kind of biggest complaint of people who want to reach me. Their emails are not formally written. Okay. I would want you introduce in the first paragraph yourself. Okay, even if this is the 7th email you are sending me, okay, you introduce yourself in the first line or so, and then you kind of specify what the problem that you want my help with, or whatever that is, okay, with some context. My office is on the 6th floor, but I would hardly ever be physically available, okay? I'll mostly be available on Slack. All right, that's how you can reach me out. Any questions so far? Are we good? Okay. So the game we are going to play is that we are going to learn discrete structures or quantitative reasoning together, and there are a few rules that we're going to follow, okay? The first rule is that you are either going to call me Dr. Mudassir, or you're going to call me Professor or Professor Mudassir, or you're just going to call me Mudassir, okay? You're not going to call me Sir Mudassir, okay? I kind of hate that word because this is somewhat informal, okay? इसका कोई मतलब, this does not kind of formalize our relation. Okay? Our relation is I'm your professor, right? So that's probably what you should use. If you want to be informal, just call me Mudassir. I don't have a problem with that. Okay? Let's quickly do an experiment. Okay? So you have 3 choices. You can call me Dr. Mudassir, Professor Mudassir, or just Mudassir. Okay? I'll count to 3, and each one of you is going to shout out at the loudest possible whatever you're going to call me for the rest of the semester. Okay? Ready? Everyone has made up their mind? Okay? 1, 2, 3. Oh my God, this is every time the answer. Okay, good, cool. That works, okay? Professor Mudassir works. Or you can just call me Prof or Professor, okay? All right, so that's the first rule. The second rule is you're going to have your cell phones turned off during the whole of this class, okay? Not on silence, not on, I don't know, put down, turned off. Turn them off right now. Go ahead. So if there is some emergency and you need to be available during the class, you come to me before the class and tell me that this is my emergency and I need to take a call or need to be available on call, and I'll let you keep your phone on, okay? But other than that, your phone should always be off, okay? If I find out, and if it rings, or if I find out your screen is blinking or whatever, there are going to be punishments for that, okay? The third rule is you are supposed to be here on time. Our class starts at 1 p.m. I expect everyone to be here at 1:05, okay? If you are late more than 5 minutes, do not enter the classroom, okay? First of all, I won't let you, okay? I won't let you come in. The second is that I will note your face and name, okay? Which is going to be problematic for you, okay? All right? Do we all agree on this? That we will always be on time? Raise your hands and commit to this, that we will be on time. And if by some reason, keep your hands raised, please. If by some accident we are late more than 5 minutes, we will not enter the classroom. Yes? Yes. Louder? Yes. Okay, awesome. Thank you. No whispering. I hate people talking to each other during the classroom. I'll give you a time when you can talk to each other, but during my lecture you will not talk to each other. Okay? You will talk to me. If you have anything to say, talk to me. If you have problem with the material that I'm delivering, talk to me. If you have a joke to tell, talk to me. Raise your hand and say that there's a joke I need to tell someone, okay? And I'll give you stage and you'll tell it to everyone, okay? If you don't want to come to the stage, you want to tell it in secret, I'll give you my ear, okay? Don't worry about it. You can say anything you want, but you have to talk to me. You need to involve me in the conversation. Agreed? Yes. Okay, awesome. I want you to be honest and courteous in class. I think what I believe is during this whole semester, if you learn anything about discrete structures and you fail this course, that's kind of fine with me. I don't have a problem with me. There are students who failed this class for me, and I wrote their recommendation letters, and they are in some crazy place in US doing great. But both of us have respect for each other. The reason being, they were always honest with me. Okay? If there is a quiz, there is a homework, we need to have a mutual respect. If we lose that thing, तो फिर the thing जो मैंने अभी आपको कही कि you need to call me professor, वो फिर उसका कोई फ़ायदा नहीं रह जाता. Okay? You'll be saying professor but you would never mean it. हमारा relationship नहीं रहेगा. Okay? Our relationship is based on mutual trust. You need to be honest. मैं उसकी आपको एक दो examples दे देता हूँ. एक of course मैंने आपको दी कि plagiarism is absolutely, strictly unacceptable in this class. Okay? Second part is very light instructions. For example, if you are doing a quiz in the class and I ask you that your time is up, stop writing. You should stop writing, regardless that there is some tiny part of the answer that's left जो अभी आपने लिखना है. When I tell you that you stop writing, you would stop writing. Okay? Do you guys all agree to this? Yes. Right? These are the rules of the game. You need to agree to participate in this game. Okay? Do I have all of you on board? Yes? 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 Yes. Okay. Cool. Moving on. Any questions? Any comments? Okay. This is the book that we are going to use. These slides are, by the way, going to be available. Okay. For the slides, I'll make sure that I'll get the slides to you within a couple of days. Okay. But it's not a guarantee that you would get the slides the same day or the other day. Okay. It's kind of a courtesy on my behalf that I'm giving you these slides. What I expect from you guys to be able to do is to kind of be note down, take notes or whatever if you need to, okay? But the whole activity of the class, you need to be able to record it, either in your brain or on paper, whatever works for you, okay? The slides are kind of a courtesy on my behalf, which I'm sharing with you, okay? All right, so we are going to use discrete mathematics in its application by Kenneth Rosen. We use 7th edition. I think there is also an 8th edition which works. So it's not going to be a big trouble कि edition आप कौन सा ले रहे हैं. But I think there are about 5 or 6 copies of this book available in the library, so you can go and check it out. Do you really need to buy this book? Okay, I won't I won't insist on it, okay? कि अगर आपके पास book नहीं है तो you'll fail this course. That's not going to be the case. What you are going to be able to live with, what you're going to be able to live with is if you consult the book on kind of daily or at least twice a week basis, okay? Which means that if you go to the library, you pick up the book and spend a couple of hours looking at the problems which are similar to the problems that we discuss in the class, you're going to be okay. That will work. Are we good? Communication. We are going to use a Google Classroom, and here's the link for the Google Classroom. I kind of made it easy to read, so you go to tinyurl.com/f24. This is fall 24 class. That will take you to the invitation of the Google Classroom. Okay. We'll also use Slack, which is f24 Slack, tinyurl.com. On Google Classroom, you'll see class material like these slides, assignments and assessments. You'll see how much you were awarded on a given quiz or homework. Okay. Slack is mostly for online discussions and announcements. Okay. If there's going to be, God forbid, a class cancellation, you'll see an announcement in the Slack. If you need help with something and you need to reach out at TA, you should be able to do it using the Slack platform. Okay, don't mix the two. All right, so Slack for the communication, discussions and announcements, and Classroom for materials and assessments. Okay, awesome. So I expect that you check both of these channels on a very regular basis, okay, at least twice daily. And to help you get kickstart, I'm asking you to introduce yourself on Slack in the random channel, and I'll give you 2 points towards your first quiz for that. Okay? Your introduction should be at least 3 sentences. I think I write it there. Your name, a surprising fact about you, and what you learned in the first class. Okay? So go ahead and do this today, and you will get 2 points towards your first quiz. Also, if you have any questions or answers, feel free to ask or answer on the Slack. Okay? So you'll have full access on the Slack, which means that if people are asking questions, you should be able to answer those questions. And I'm noting that activity. Okay? That activity has points. Questions? Are we good? Okay, so this is the most kind of important part of today's class, which is I'm going to tell you about grading. There are going to be 4 homeworks that we'll share on the Google Classroom, but none of these homeworks are graded. So we don't expect you guys to submit those homeworks. We expect you guys to do those, but we don't expect you to submit those. The final exam is going to be, so these are sorted by, except for the first one, these are sorted by these numbers. Okay, the final exam is 30%. The quizzes are going to be 20%. These quizzes are mostly going to be based on the homeworks that we give you. Okay, we'll give you 1 homework per roughly a month, but we'll have about 4 or 5 quizzes each month. Okay, that will be based on the homeworks that we gave you. Apart from quizzes, we will also have class worksheets. Class worksheets we allow you to do in pairs. These are like quizzes, but one-to-one discussion is allowed. We'll make pairs, and you'll do the problems on the worksheet in pairs, so you can talk to each other. Okay? That's worksheets. Uske baad we have midterm exam, which is 15%. We also have a new component this time, show and tell. I think I have a slide about that, so I'll wait for that. There's also a group activity, which is to get you guys to work together. Okay, you will make groups of 4, 5, or 6 people. You'll get together for about half an hour to 40 minutes, and you will record the whole session. Okay, you'll pick a topic. We'll give you some topics, but given that topic, you will pick a question or a concept that we discussed in the class, and then you will spend that half an hour talking to each other or explaining to each other that concept or the solution to that problem. Okay, but you will record the whole session. You will submit the recording to us, and for that we will give you 6%. Okay, there are going to be about 4 group activities. We usually do 4, right? Yeah, there are going to be 4 group activities. So these are kind of freebies. Okay, so 6% just for doing that. Okay, you could be doing a problem, but you might be doing it completely wrong. Okay, we won't punish you for doing it wrong. We'll punish you for not doing it. Okay. Class participation is 4%. This is actually class and online participation. Okay. I'll see how you are participating on the Slack channel and how you participate in the class. Okay. Any questions? Does it sum up to 100? I was actually making this before the class. I changed a few things from the last. This is 100, right? Okay. Good. Awesome. Questions? No? All right, okay, let's get going. Show and tell, yeah. So show and tell is going to be a series of presentations. Okay, we decided that we will have 3 of those. Roughly 5 weeks from now would be the first session. In each session we will have 5 presentations. Presentations would be in the groups of 4 to 5 people. And each group will present only once during the whole term. Okay. So the question becomes, who will be the first group to present in the 5 weeks? Okay. I'll take volunteers if someone says that our group is going to do the first presentation. But if there are no volunteers, I would do the random ordering. Okay. I'll pick some people, and I'll give you 2 weeks to prepare those presentations, and you can give those presentations. Presentations are going to be about 10 to 15 minutes each. This activity is designed and owned by Saleha Shoaib, who was here a moment ago. So you can reach out about the details. Okay? Questions? All right. By this time, usually people have asked few questions. All right. Okay. So this is the scale of the grading. The grading is in general relative, but I kind of honor these boundaries almost meticulously. Okay. If you score more than 90, you are almost certain to get an A, and if you score less than 60, you are certain to get an F. Okay. But apart from that, there could be margins of few points here and there. Okay. This is kind of the summary of the whole of discrete structures. Almost everything that we are going to talk about is here. All right. Let me ask you guys. Okay. Let me involve you guys. What do you guys think these things are? Okay. Let's start with logic. What do you guys think is logic in the context of this discrete structures class?
It could be a bunch of AND or if-else statements.
Good. So, what's your name?
Nofil.
Okay. Nofil says that it could be a bunch of and or not type of statements. That's what you said, right? Okay. Anyone wants to add on that?
It is a thought process behind the solution of a problem.
There's a thought process behind the solution of a problem. Okay, good, nice. Okay. To prove
What we have done or
okay, awesome, good.
A combination of relational operators.
A combination of relational operators. Okay, nice. Okay, good.
arguments for what we have shown.
Arguments for what we have shown. Okay. Awesome. Really good idea. And almost all of them are correct. To combine all of these, the thing is, the way humans or us communicate is through a language, right? And the languages that we use for this communication happens to be ambiguous. Okay? At times, our language needs supplements. At times it happens that someone gives you a sentence which is grammatically perfectly correct, but then you ask them, what do you mean? Can you rephrase this? Right? There is at times need for this. Okay? There are words with double meanings. There are sentences with double meanings. Right? That creates a problem for a word where you want to be deterministic about things, where you want to be sure that if I take these 5 steps, I will always get this promised output. Okay, that's the word of computer science, right? Where you want to be deterministic, right? Logic is a foundation or a language that we design to study computer science, which is unambiguous, unequivocal. The sentence that I write down using relational operators, AND operator, NOT operator, or whatever, what I'm trying to convey is an idea that cannot be misinterpreted. Okay? It should always mean the same thing in any word you go. Okay? If there is an alien coming, you just give them a set of logic rules. They would always be able to reach the same conclusion that we reach in this word. Okay? So that's what logic is. That's what's fundamental about logic. That it's a language that is absolutely unequivocal and unambiguous. Okay? Cool. Thanks a lot, man. I got this. Thank you. Okay, proofs. What are proofs? So proofs are in the language of logic. In the language of logic, proofs are a series of deductions and based on justifications. Okay, where each step is easily justifiable. Okay, so going from start to end, you start with some statement and you end with some statement. this step-by-step process is proof if each step is logically true and easily deducible. Okay? दो चीज़ें हैं उसका पार्ट. एक तो it must be true कि वो गलत नहीं होना चाहिए किसी स्टेप के ऊपर ना. And the second part is each step should be easily deducible. उसको किसी को कन्विंस करने की ज़रूरत ना पड़े कि इस स्टेप से दूसरे स्टेप से तीसरे स्टेप पे आप कैसे गए. Okay? So that's proof. Sets? That should be easily definable. What is a set?
Well-defined set.
Collection of distinct
objects. Well-defined set of distinct objects.
Well-defined?
Distinct objects.
Well-defined distinct objects?
collection of distinct objects.
Collection of?
Distinct objects.
Collection of distinct objects? I'm still missing one keyword here.
Well-defined is well-defined collection of distinct.
No, well-defined is not the word I'm looking for. Unrepeated. So distinct is there, right? Distinct means that you cannot repeat them. But good.
With similar qualities.
No, not at all. That was a lie. That was told to you in high school. Okay? Oh, we don't care about how similar they are. Okay?
Comparing different things. Very good.
There's one nice thing that you kind of all have that in your mind, but you are not able to express it. Because you kind of assume that ये तो होगा, ये तो definitely, I mean, I'll tell you and you'll say, हाँ ये तो, I know this is what it means, right? What is that word? Order. Sets में order नहीं होगा. Okay? Unordered collection of distinct things. Okay? That's the set. Order, what that means is, why do I need to say this? Okay? The reason I need to say this is, when I write 1, 2, 3, and then I write 3, 1, 2, what I mean is the same object. अगर ये दोनों चीज़ें sets है ना, I mean the same object. Okay? अगर मैं unordered नहीं कहूँगा, तो फिर these two things could be different. Okay? And when I order them, I get a different object. Okay? Okay, nice. So that's what sets is. We'll talk about sets. Functions, can anyone define it? I'm not going to define function, by the way, but I just want to hear what people have to say. What function is?
It is a program which takes inputs and gives certain outputs.
Good point. Okay. It's a program which takes some inputs and throws out some outputs. Okay?
For each input, we have only one output.
That's actually more of what I was going for. For each input, you have only one. Okay? So you cannot get two different outputs for the same input. Okay, good. Moving on. Binary relations. Okay, let's skip that. Okay, because that requires some context. Computation. Anyone about computations? Compute?
Calculation.
Why?
Processing.
Okay, so this is about how to define it at this point. The amount of computational resources required to do something. Properties of integers, counting. That's kind of the last two things are my kind of. Actually, everything is my favorite, but counting and graphs. We'll spend last few weeks on those. Everything before counting is kind of a ingredient. Okay, it's kind of things that we need, or counting and graphs are kind of a recipe. Okay. Just keep this thing in mind. When we come to counting, I'll repeat this sentence and I'll ask you, are you convinced that this is what it was? Okay? Everything up till counting is kind of an ingredient. And then we come to counting, we'll talk about recipes. Okay? We'll talk about creating new things. Okay? Questions? All right. Let's start with an application. So let's say you work at a company that wants to market a new cell phone. Okay. So no one knows about their cell phone. They create this new amazing cell phone. What they want to do is they want to give away fewest number of those cell phones to people around, so that almost everyone knows about their product. Okay, that's a typical marketing strategy, that you create a product and now you want to spend some money to convince a very few set of people. जिनको हम influencers कहते हैं, we give them away a few things to even review, and then since they are influencers, so they have a larger circle of people who are connected to them. So if they know about your product, a lot of people are going to know about your problem. Okay, so that's a typical problem. It turns out it's a discrete math problem. Okay, if it's a discrete math problem, then we should be able to see some of these objects there. Okay, well, let's see how we find those. So there is this relationship among people, which is that I know him, or he is my friend, or he's my neighbor, or he's influenced by this person. Okay, that's a relation. We need to model that relation, and that relationship is modeled by something called a graph. Okay, so what happens in graph is that we represent entities, or in this case इस example में जो individuals हैं, humans हैं, part of society, या जिस community को आप target कर रहे हैं. For example, you only want to target people in Lahore. Okay, so everyone in Lahore would be kind of a circle in this graph. Okay, इस चीज़ को मैं graph कह रहा हूँ. This is different from the graphical thing that you make XY coordinates के अंदर. Okay, Cartesian जो आपके sorry हाँ कार्टेशियन कोऑर्डिनेट्स के अंदर जो चीज़ बनाते हैं. इट्स इररिलेवेंट कि मैंने इसको कहाँ पे बनाया है. ओके, इसकी लोकेशन से कोई फ़र्क नहीं पड़ता. इट्स अ डिस्क्रीट ऑब्जेक्ट. Okay, so that's that, and then I connect two dots if they are friends with each other. Okay, if one has a phone, the other definitely knows that this guy has this new phone. Okay, so that's how I can kind of map this relation, and this thing is the graph का structure इसको हम कहते हैं. Does everyone know what a graph is by now? Okay, so it's a bunch of entities and the relationship between pairs of those. Okay, so some pairs have that relation, some pairs do not. So for example, अगर मैं इनको label कर दूँ 1, 2, 3, 4, तो फिर 1 and 2 have a relation, but 1 and 3 do not have a relation. Okay, so what that would mean is कि 1 and 2 are friends, 2 and 3 are also friends, but 1 and 3 are not friends. Are we good? Okay, so that's where we use graph theory to model such relations. Now, so how many free cells are needed to cover the whole graph? 3, 4, 5? So if I have, for example, these 5, someone said 4. Who said 4? Okay. So if I give phones to these 5 people, then you'll see that everyone is covered, right? Everyone either has a cell phone or their friend has a cell phone. Okay? So this guy's friend has this. Everyone is connected to someone who has a phone, right? Right? Which means that 5 cell phones are enough. If I give away 5 cell phones, then the whole graph would be covered, and my marketing strategy would be kind of successful. He says, what's your name? Ali. Ali says that we can do it with 4. How can we do it with 4?
Sir, in the modeling friendship,
What did you just call me?
Professor, in the modeling friendship, it said that we should represent the phone with the corner edges and not in the center.
Okay, that's okay. Repeat it again one more time.
In the modeling friendship before this slide,
Yeah.
said that we should represent friendship as edges and not in the center.
So, okay, so modeling a friendship is just this line segment. Okay, this line segment tells you that these two people are connected, right? At this point, we are just deciding. Okay, so question is, are there 4 people here who could be the good influencers? If I give them phones, then everyone will know about the phone that I'm giving away. So are there 4 people here who could be my influencers? Yes? Anyone? This is not that hard a problem, is it? बोलो center में बोलो. So let me label these, okay? Let's say this is 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14, okay?
Center 4.
So this is 13 and 14. Give me the number of the nodes. If I give them cell phones, I would have everyone.
Center 1 and 4.
So you're saying that if I give them to, what was this number? I forgot about it. 6, 7, 11, 12. Then everyone would be covered. Is that true? Is that true? I think you're right. Which one?
The one at the end.
ये रह जाएगा, है ना? ये रह जाएगा. Good catch. Anyone else? क्या?
If we give the phones to these three in a circle and the one.
Give me the numbers of the three. So this is 5, okay? This is 9, and this is 13, sorry. So give me the number of 3. Okay, क्या?
अगर हम 4 सेल फोन यूज करें तो कवरेज हो सकती है सर.
Okay, बोलो कौन से
अगर हम 2 पे रखें,
एक 2 पे रख रहे हो, ओके?
एक 8 पे रखें,
यहाँ पे, ओके?
एक हम 9 पे रखें
यहाँ पे, ओके?
और एक 14 पे.
14. Okay, 2, 8, 9, 14. Let's check. 2 covers this thing, right? 2 covers these 3 things. Oh, how would you cover this thing? 3. Oh, 2 se cover ho jayega. Okay, so 2 se you will be cover 1, 2 and 3 and 6. Okay. If you have this, you would be covering this guy, sorry, and this, and then you have this covers these 2, and then you have 14, right? Yeah, I guess that works. Good. Okay, nice. So 4 works. Fine, 5 phones are sufficient, but necessary question was, do we need 5? Okay, the answer is no, we don't need 5. 4 से काम चल जाएगा. Okay, and here is another solution. एक आपने दिया, which helps you find 4 phones for this. The question is, can we do better? And that's one part of what discrete math is, that you actually prove that there is no way to improve on that. Okay, for this question the answer is no. We'll see how that works. Actually, I have a slightly more interesting problem. Can you guys read the numbers in there? Let me read for you. Okay, so this is 0, this is 8, this is 7, this is 2, this is 5, 3, 6, this is 4, and this is 1. Okay, let's have a look. How many do you need for this one? You need 2. Which ones?
3 or 7.
3 and 7. Let's check it. Someone says 3 and 7. Let's check 3 and 7. I'm actually not sure that this is going to work. Boy, no. Okay. ओके, ये तो मैनुअली चेक करना पड़ेगा क्योंकि मैंने अभी ये वाला कोड ऑन नहीं किया. Okay, you said 3 and 7, right? Let's see. You want to take 2 and 7? So 7 covers 8, 4 and 1. That's right? And 0. And 3 covers 2, 5 and 6. So it works. 3 and 7 works, right? Okay, let me try doing it with the... I was doing it and there was some error in the program somewhere. I guess it's somewhere here. Oh, defining. Okay, let's do it with 10. Okay, how about this one? This is the last one, I promise.
7 and 14.
7 and what? 7 and 1. Yeah, I made them very dense. 7 and 1. Let's try. 7, 1. This is not a valid dominating set. Something must be missing. Okay. 7 is covering. I don't know what's missing. Let me just see. Now there is something wrong with this. I think you're right. 7 and 1 is the answer. Anyhow, okay. So the point I want to make here is that this is a very small, tiny graph. Okay, this is 8 nodes or 7 nodes. Do you guys know how many nodes are in the Facebook graph? There are a few billion nodes there. Okay, there are 5 billion nodes in there. Okay, think of the scale of problem this would be on a Facebook graph. Okay, even you pick a small community on a Facebook graph, people from Lahore, it would already be in millions. Okay, and this problem would be super hard to solve even on those problems. Okay, so compute becomes really important there, that you want to make sure that your solution is efficient. It does not take so much computational resources. Okay. Okay. So I would want you guys to keep the big picture in mind, और इसकी reason मैं अभी आपको 1 minute में बताता हूँ. And then be able to connect things, because see, okay, मैं बहुत पीछे जा रहा हूँ. There are a lot of moving components and they are not directly connected to each other. Okay, so you would want to be able to translate knowledge from one part of the course to another. Okay, that's what I mean by connect. And also you need to be part of dialogue. Okay, no matter how many times I repeat this always is the deficiency I always find in students, that they don't talk to me too much, okay, or the TS too much. Okay, so let me say it this way. Okay, you are not gonna be wrong overdoing it. Okay, there is no bar जहाँ पे आप कहेंगे I'm overdoing the dialogue thing. Okay, okay. Just for a summary, this course is mile wide and foot deep. What does this mean? What do you guys this mean? This is mile wide and foot deep. Yeah.
It will cover a lot of topics, but today must learn.
Absolutely. Yeah. So we are going to cover almost every other week. We're going to start a new topic, a new thing, a new, I don't know, even subtopic, and we'll move on from that topic. 2 weeks गुजरेंगे तो you'll see that you're at absolutely fresh start again. Okay, and you will lose the context of the big picture. Okay, that's why it's really important to keep the big picture in mind. Okay, I'll try to keep reminding you कि हमने last क्या पढ़ा था और अब हम क्या पढ़ रहे हैं, but you need to keep that in mind. Okay, participate again. I'm kind of broken pipe की तरह मैं आपको बार-बार कह रहा हूँ. You need to participate more and more. Okay. This is a complaint I hear a lot, that I'm kind of going to make sure that you understand everything in class. That's not going to be a problem. That's usually not the problem, that you're in the class, you're coming to the class, and there is something that you don't understand in the class. The problem is usually that when you go back home and you look at the homework or the quiz, you are totally blank. You have no idea how to solve those problems. Okay? And the way it works is that you get to practice a lot. Okay, you'll see a lot of practice problem on the slides in class, and these guys, Mehreen is here, Barira, they're going to be available on Slack. They'll point to problems in book which are related to the problems in book in the slides, and your job is going to pick that up and do the problems from the book. जो हमने क्लास में डिस्कस नहीं किए होंगे. Okay? वो अगर आप नहीं करेंगे तो you will lag behind. फिर आपसे क्विज नहीं होगा, फिर आपसे एग्जाम नहीं होगा. You will fail this course. Okay? All right, let's start with another example based on logic. Let's read this. So we have two statements. One of them is a thief. So we have three people, A, B, and C. A says, I am not the thief. B says, A is the thief. And C says, I am not the thief. Okay? We know two statements to be true. One of them is definitely thief. Exactly one of them is speaking the truth. Okay? Based on this, we want to conclude or find out who the thief is. Okay? Let's see how we do it. Pay attention to the process and not the answer. Okay? You might jump to the answer. Okay, I know this guy is the thief. But the more important part is the process. The process, we're trying here to formalize or systemize the process that we use to reach the conclusion. Okay? So we start by supposing things. We suppose that A is thief. If this is the case, then both B and C are speaking truth, right? C is saying that I'm not the thief. If A is thief and there is only one thief, then C is definitely speaking the truth, right? And B is saying that A is thief, which means that B is also speaking the truth. But that's not possible, right? Because we know that exactly one of them is speaking the truth, right? So that's the process that we used to eliminate the statement that A is the thief. How much time? How am I doing on time? ये clock ठीक है? क्या? Okay. नहीं, 10 minute पीछे. Alright, so we use this process of elimination to eliminate one of the supposed conclusions. Okay? If we reach there, the second thing is we assume that B is the thief. Can you argue about why B is or is not the thief before looking at the next slide?
B is not the thief because A is also saying that he is not the thief and C is also saying that he is not the thief. So two correct statements.
Okay. So if B is the thief, there are two statements which seems true. Okay, where A says that I am not thief and C says I am not thief. Okay, which means that you want to add something.
C is the thief.
Yeah. So again, the thing is, we on this slide we proved that the statement that B is thief is wrong. Okay, because it contradicts one of the assumptions that we started with. Once we know that A and B are not thieves, then the statement that exactly one of them is thief gives us the answer, which is that C must be the thief. Okay, and we can verify the statement as well that this agrees with our original hypothesis. All right. Okay. So again, pay attention to the process that we are using to reach a conclusion. This problem could become extremely complex pretty easily, okay, assuming that you have, for example, n people and exactly k of them are speaking the truth, and you have a few bunch of other constraints as well. That's why it's important to kind of formalize the system or systemize the process instead of just concluding a solution. Okay. Let's look at another example. Our focus again is on the process of reasoning. We have three statements. One is it's snowing in New York. I should write New York City, but in any case, if it snows in a city, then its schools are closed. That's the second statement. And the third statement is that if it snows in New York, then it snows in Boston. Okay. What do we want to do? We want to conclude from these three statements that schools in Boston are closed. Can we do this? It seems that we can. And here's the process. Okay, these are the statements that we have, and we made boxes for those statements. And then the relationships could be arrows. Okay. From the first statement, I can deduce the second. Okay. since it's snowing in New York, and I have that if it snows in New York, then it snows in Boston, this arrow is valid. Okay, it tells me that it's snowing in Boston. ये वाला arrow मुझे कैसे मिला?
Second statement.
Yeah, from this statement. This statement says that if it snows in a city, then it's. Oh, hold on a second. Yeah, second statement, which says that if it snows in a city, then schools are closed. Which means that if I plug in city with Boston, I would get this statement, which says the schools are closed in Boston. Okay. I also get a separate statement, जो required नहीं थी मेरे लिए, which says that schools are closed in New York. Okay. Are you following me? Are we on the same page? Okay. So to formalize, we have a bunch of statements. Okay. And then we have kind of something about these statements, which is that either these statements are true or false. Yes or no. Okay. That's going to be our groundbreaking. Okay, that's going to be our ground on which we are going to build or I don't know, building. Okay. What do you guys think? How would you define the statement? What's the statement mathematically? If this is our ground needs to be solid, right? We should unequivocally, unarguably know what each of those breaks are, right? So statement seems to be one of those breaks. So what is a statement?
Proposition that
You're using the words which are breaks that we don't know about yet. Okay? Let's use things which are unequivocal, unarguably we know about them before we embark on this journey of defining things for logic, right? So how would you define a statement?
Something which is permanent or unambiguous. I mean, it doesn't change over the course of others.
Okay. Okay. Yes.
repetitions of facts.
Yeah. So the way I would define it is that it has a truth value. Okay. It's either true or false or both. Okay. So there could be statements which are simultaneously either true or false. Okay. So a statement is जिसके बारे में हम ये कह सकें कि ये या तो yes है या कोई कह सके. Okay. Again मैं इसको थोड़ा और broad कर रहा हूँ ना. Statement is anything जिसके बारे में या तो कहा जा सके कि this is a fact या कहा जा सके कि it's not a fact या कहा जा सके कि maybe it's a fact or maybe it's not a fact. Okay. इससे ज़्यादा we cannot be more general, right? This is as general as we can get. Do we agree on this definition of statement? Okay, let's move on then. What could be a good way to capture relations between statements? I talked about it a moment ago that what we are going to do in proofs is that we will have statements and we are going to have relationship between statements, which would be if I have this statement, then I definitely have this statement. Okay, that could be one possible relation. Another possible relation could be that if this statement is true, then this statement is definitely false. This could be another relation, right? So you can define connections between statements in this way. इसको हम थोड़ा सा और formalize करेंगे. But these two connections should be obvious. If I have a statement, if it's true, this other statement is also true. This is a very simple relation. Okay. Another relation is that if this statement is false, this other statement is definitely true. Okay? How can we write new statements from new ones? That's also we're going to learn कि हम ये कैसे करेंगे. For that we were going to need operations. जो थोड़ी देर पहले लोग कह रहे थे कि हम आपने शायद कहा था कि we can use and, we can use or, and we can use not operator. Okay? All right. This kind of formalization gives us a way to create precise mathematical arguments, proving them by these connections, and verifying correctness of computer programs. Okay, designing computer circuits, writing algorithms. Okay, and to pass this course as well, right? Okay. I just want to quickly start chapter 1 so that you have something in mind before we meet tomorrow. And that's going to be formally starting chapter 1. And that starts with a definition of proposition. Okay? Proposition is a subset of statements which definitely have a truth value. Okay? It's either true or false, but not both. They cannot be simultaneously both. Okay? This distinction is important, that they cannot be simultaneously true or false. यहाँ पे एक और चीज़ ये भी है, actually हम ये examples देखेंगे तो it will make itself clear. Let's see, 29 is a prime number. Is it a proposition? You can say that it's true and you can say that it's false, right? There is definitely a truth value. It cannot be simultaneously true and false, right? But it looks like a proposition. Okay, so that's a yes, and it's also true as it happens to be true. Okay, either way, it is actually a proposition, and the reason is that the statement is definitely either yes or false, yes or no. Okay. Right now, at given state of time. Okay, इसको थोड़ा सा specify करना पड़ेगा. You will have to define time in the physics terms. वो सारा कुछ करना पड़ेगा. But in kind of Newtonian physics, this is a proposition. Okay, at any given time, Earth is either the only planet with life or it's not. Okay, it's not. There is no variable there. Okay, यहाँ पे ऐसा नहीं है कि अगर यहाँ पे टाइम का वेरिएबल आप इंट्रोड्यूस करवा दें तो देन मे बी दिस बिकम्स अ नॉन प्रोपोजिशन. एंड एट सम गिवन टाइम अर्थ इज द ओनली प्लैनेट विद लाइफ एंड सम अदर टाइम इट्स नॉट. ओके, लेकिन अगर टाइम वेरिएबल यहाँ पे नहीं है, आप स्पेसिफिक फिक्स टाइम की बात करें, देन दिस इज अ प्रोपोजिशन. ओके, काइंड ऑफ रिलेटिंग इट टू द प्रीवियस स्टेटमेंट. अगर एक्स एंड वाई नोन नहीं है आप लोगों को तो दिस इज नॉट अ प्रोपोजिशन. Okay, x and y known है तो फिर this is a proposition. Are we good? Yes. Okay. For every positive integer there is a prime number larger than n. Is it a proposition? Yes, no? Eyes? Yes? Oh, that's scary. Why do you guys think this is not a proposition? What's wrong there? It's definitely yes, right? For every positive integer there is a prime number larger than n. Okay? So the thing is, n is not a variable here. N is a quantifier. And it's not a variable. You don't need to know n to tell me this statement is true or false. Okay? ठीक है, अलजबरा यहाँ पे थोड़ा सा आपको रिपीट करने की ज़रूरत है. इस स्टेटमेंट को प्रूफ करने के लिए या इसको ट्रू स्पेसिफाई करने के लिए या फॉल्स स्पेसिफाई करने के लिए यू डोंट नीड टू नो द वैल्यू ऑफ n. ओके, दैट्स व्हाई दिस इज प्रोपोजिशन. कंपेयर टू x plus y is more than 5, उसके लिए आपको x और y की वैल्यू चाहिए, बिकॉज फॉर सम वैल्यूज ऑफ x and y द स्टेटमेंट इज ट्रू, फॉर सम वैल्यूज ऑफ x and y द स्टेटमेंट इज नॉट ट्रू. Okay, so that distinction is important. I think I want to stop here. I want to hear you guys. Do you guys have any questions? Do you guys understand what proposition is? I want to hear examples of question or example of propositions or based on this. Do you have any example in mind that might be confusing, that may or may not be proposition? So this one is tricky. I almost always get into tangles discussing this. Okay, Earth is a planet, is the only planet where life exists, right? Because of the time thing, right? Because space and time are kind of related. You cannot define space without time. Anyhow, but do you guys have any interesting examples in mind? No? Yeah?
Earth revolves around the sun.
Earth revolves around the sun. Yeah, again, if you fix a time, us, for example, you say that today Earth revolved around the sun. That's a proposition. Okay. But again, अगर time को variable ले लें तो फिर it's not a proposition, right? There was a time when Earth was not revolving around the sun. There will be a time when Earth will not be revolving around the sun, and there is definitely a time when Earth is actually revolving around the sun, right? So its statement itself is simultaneously true and false, unless you fix the time. Good point. Okay. Yeah.
Everything in the universe is revolving around something.
Yeah, everything in the universe is revolving around something. Yeah, that's probably true. I don't know. Yeah, I don't know. Okay, हम अब बहुत serious physics में जा रहे हैं. Let's stick to computer science. All right. Any questions? Anything I did not talk about today logistically? कोई चीज़ आप लोगों को मेरे से चाहिए हो? Yes? No? Yeah?
But if you have something like a statement that we're not sure of that it is true or false,
Yeah?
like there is a case that if both are true or both are false or that both are something. But what if we do not know that anything is true?
So good point. So what's your name?
Sarah.
Sarah?
Sarah.
Okay. So the question is, if there is a statement and you are not sure about whether it's true or false, okay, that does not make that statement a non-proposition. What makes a statement non-proposition is the fact that you know that the statement is true for some variables within the statement and false for some variables within the statement. It's possible, for example, again, मैं वही example दे रहा हूँ line 4 की, I don't know the statement is true. For example, at this moment, it might be true or it might be false. Okay, if we fix time somehow, the statement might be true or false, and I don't know about that. Okay, not knowing about that does not give me a hint about simultaneous different truth values of the statement. Okay, it's possible that there is a proposition whose truth value is not known to me. Okay, let me repeat that sentence. It's possible for a proposition for which no one knows the truth value. Okay, but you look at the statement and you kind of deduce that there's definitely a truth value for the statement, that the statement is either true or false. It's just that the statement is so complex that no one really knows the answer to the statement. Okay.
So what about this proposition? There are 365 days in a year.
There are 365 days in a year. Okay. The statement. What do you guys think? What do you think? I have an answer.
So it can be false when there is a leap year.
So, देखो, and it's a very good example. Okay, I really appreciate you for that. It is a proposition. Okay. The thing is, जो आपने statement दिया ना, it has a connotation in there. When you say that there are 365 days in a year, what you actually mean is that for every year there are 365 days in that year. Okay, that's not, you don't say it, but that's what you mean when you say that there are 365 days in a year. What you mean is that for every year there are 365 days in a year. Okay, so the truth value for the statement is false, but the statement itself is a proposition. It has a truth value. Okay, it's a no. Does that make sense? Okay, good example. I'll probably add it to my slides. Yeah. Yeah, the creatures living on Earth. Yeah, again, हम quantum physics में जा रहे हैं कि can two things simultaneously be present at two different places? Yeah, okay.
So is time travel possible?
Is time travel possible? Yeah, okay. Okay, मैंने नहीं पढ़ी इतनी physics. Okay, I just remove these things. Okay, sorry about that. But yeah, okay. So that's a proposition, right? This is either true or false. This is a proposition, and this is also a proposition, right? This is either true or false. Yeah, good examples of propositions. Think of an example of a non-proposition.
This classroom has a lot of students.
Yeah, but it's a proposition, right?
No,
Why it's not a proposition?
because it depends on what you make out of it.
What you make out of that. Yeah. Okay. Good. ठीक है. I agree with you. So when you write it mathematically, you would have to specify a variable for lot, and then if you leave that variable undefined, then this statement would not be a proposition, right? So I don't know. You would. What I mean is, you would write that number of people in this room is greater than X. Okay. If you write it like this is not a proposition, right? Because X is not defined. Good. Yeah. Square root of negative numbers exist. Yeah. Definitely. That's a proposition. What?
Proposition.
Yeah, it's a proposition, right? Right? It's based on rules of mathematics. It's either true or false. Okay? In some mathematics, this is true. In some mathematics, it's not. Right? Right? If you include imaginary numbers, it's true. It's otherwise it's not. No. So again, okay. Now we are into examples which you need to write formally to deduce that they are either proposition or not. Okay. If you write it, yeah, I'll ask you to repeat the statement so that I kind of figure out what. Square root of negative numbers exist. Okay, so by this statement, it means that you're including every possible form of knowledge, which means it's a proposition, and it's true. Okay. Okay.
Does white hole exist?
Sorry, what?
Does white hole exist?
Okay. Yeah. That's a proposition, right?
But the scientists don't know whether it is there or not.
So again, yeah, I agree. So what's your name? Tanya, the thing is, a moment ago I kind of said that, let me repeat that statement, that for a proposition to be a proposition, you don't have to know the truth value. You just have to know that there is a truth value for the statement. Okay? So, for example, the example of time travel. Okay? We don't know it's possible or not, but there's definitely a truth value to it. It's either possible or it's not. It cannot simultaneously be possible and not possible, as far as I know. Okay? Right? So we don't know, scientists, no one knows about the truth value of this proposition, but it's definitely a proposition. Okay? Make sense? Okay. All right. What you guys need to do is go to Slack, introduce yourself, and hopefully I'll share the slides, go through the slides, and we'll meet tomorrow at 1 p.m. hopefully in our specified room, which is electronics lab. Okay? Thank you guys. See you.
Can you pull up the